So, I want to remind you guys that while we're doing stuff, I am recording the things that we talk about, the stuff that we do, and it is posted to Microsoft Teams so that should you be absent, you can hop onto our Microsoft Teams, follow the link to YouTube, or just go straight to YouTube and type DeWeed off, and my channel will pop up. All the videos are there. For all of my Math 9 classes, and some old Math 9 classes, and some physics, that's great. Yes, Hassan. 23, adding and subtracting fractions. Before we launch into that, I'm going to pause this and do it. Here we go. Adding and subtracting fractions. Adding and subtracting fractions is easy if the denominators are the same, because the denominator just determines what kind of mathematical object or what kind of fraction. You have a writing utensil? Get it out. Yeah, pick it up. We're going to make notes. Determines what kind of fraction you have. So if I have 2/5 and 1/5, the mathematical object we have are fifths. It's like adding apples. If you have 2 apples and another apple, those are just real world objects as opposed to math objects. If the denominators are the same, it's easy. If I have 2/5 and I add to those 2/5 another fifth, what I'm doing is I'm just adding up all my fifths. How many fifths do I have if I have 2/5 and a fifth? I have 3. Yes, I do. That's nice and easy. So subtraction is the same. If I have 4/5 and I decide to take away a fifth, how many fifths do I have now? 3. And so when you actually say it out loud and you use the language that we're talking about, it's easy to kind of, I hope you do too. Hassan, you did it very easily. I hope it's easy to kind of see what's going on. I mean, I have 4 apples. Now I take away an apple. Now I have 3 apples. Like these fractions are just mathematical objects that we have more than one of. 4/5, 1/5, 2/5. And so when I want to add or subtract them, as long as I have the same kind of mathematical object, i.e. the denominators are all the same, it's easy. We just go across the top and leave the denominator alone, because the denominator just tells us what this object is. It's not like you added 3 apples and 2 apples and got an orange. That would be weird. We'd have to have a conversation about that. The interesting thing happens, though, when we have different kinds of denominators, and so we're going to model this using a pizza. If I have a half a pizza and I have 3/4 of a pizza, and I wanted to see how much pizza I had altogether, I mean, for some of you it might be really easy to see, but for some of us it might be, this is weird. How am I going to add the half a pizza and the 3/4 of a pizza? How much pizza is all there? You could just start taking things out of this box and adding it to this box, like I do once my kids are done eating. But we do math kind of abstractly. We don't actually have boxes of numbers of math, and so we actually have to go and figure out a way to demonstrate this abstractly. So what we do is we take our half and we chop it into half, because a half of a half is what kind of fraction? How do these pieces relate to these pieces? Hassan, just look at the picture. Tell me. Yes, Garrett. Yes. So by cutting the half in half, I created 2 pieces that are the same size as these pieces, and now we just count them up. I have 1, 2, 3, 4, 5 quarters. The question is, I mean, aside from getting a knife and cutting it up, how do I jump from here to there? So this is the opposite of what I tried to get you guys to do before. Before, what I was getting you guys to do is I said, I have this large fraction. Let's say I have 4, no, let's make it easier. Let's say I had 6/8. And we had that fraction. I said, okay, we're going to get into the habit of writing this fraction in simplest terms as the lowest possible version of that fraction. So I had you guys look and say, okay, well, this is a 6 and that's an 8, so both of those are divisible by, because they're even, good. So I divide by 2, I divide by 2. And so the simplest version of that fraction is 3/4. These fractions are equivalent. It means they mean the same thing, but they are slightly different, but functionally equal. What we want to do is exactly the opposite of that. We want to take this half. I've got a half and a third, and what I want to do is I want to take these 2 fractions and I want to chop them up into pieces that are the same size as each other. And here, I've got my halves, and I've got my fourths. 2 and 4 they both can multiply up to the same number. In this case, they both multiply up to 4. So I don't have to change this one. I just have to cut this pizza in half. So mathematically, what did we do to go from 1 over 2 to 2 over 4? Or you can think, what did we do? What happened when we cut the pizza in half? Garrett? Yeah, we got twice as many pieces, or we cut the thing in 2. Very good. So, whatever we do to the denominator, just like here, when we were simplifying things, whatever we do to the denominator, we also have to do to the numerator. We have to be able to do it to both. So when I went from 1/2 to 2/4, what we did was we multiplied that guy by 2, we multiplied that guy by 2, and got 2/4. We doubled the amount of pizza we had. And now we're able to add those. We can count them up 1, 2, 3, 4, 5, or we can say, well, my denominator is the same here. So now I'm just going to add across the top, and I've got 5/4. This is all adding and subtracting fractions is. It gets more interesting when we start to bring in mixed numbers and improper fractions, but this is all it is. So let's demonstrate some tools that we can use to help us with this. One of the concepts that can help us with this is the concept of the least common multiple. The least common multiple is the smallest number that two numbers both multiply up to get to. Now, when you're creating common denominators here, they don't all have to be the lowest common denominator. I could have cut these pieces into more pieces. I could have cut this quarter again, and this quarter again, and this quarter again, and this quarter again, and this quarter again. How many pieces would I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd have 10 of them. But now they're not quarters anymore, they're eighths. But 10/8 and 5/4 are the same because I can simplify them into each other. So you don't have to necessarily find the least common multiple, but the least common multiple will mean that you don't have to do quite so much simplifying later. So we can make charts. We can use the multiplication table as well, but we can use a chart to help us with this if the numbers aren't already beside each other. So if we take a look at our multiplication chart, and we're like, okay, I have two numbers, I have 2 and 3, and I want to find the least common multiple. What we do is we march our way down the chart until we hit the same number. In this case, the least common could be 6. Again, it doesn't have to be least. We can keep going until we hit 12. But least will make your life easier. So what do I have to multiply 3 by to get to 6? Well, I go from 3 down to 6, it's 2. What do I do with the 2? Well, 2 down to 6 and over is 3. So we can use this to help us with what we're going to be doing here. So least common multiples of 2 and 3. Or you can just do it in your head. Multiples of 2 are 2, 4, 6, 8, 10, 12. And multiples of 3, just by counting up by 3s, 3, 6. You can stop as soon as you see a pair. And so I often see students, they don't necessarily pull out the multiplication tables, but they will make the lists of the multiples. We can do the same thing with any set. 3 and 5. Well, 3 goes 3, 6, 9, 12, 15, 18, 21. 5 goes 5, 10, 15. There they are. Again, or we could look at the table. I've got 3 and 5. I just march down until I hit, no, I don't have 3 and 5. I do have 3 and 5. I just march down until I hit, I can find a common. I got 15 and 15. What is interesting about 2 and 3 with their least common multiple and 3 and 5 and their least common multiple? Hello, Zach. Where's your stuff, dude? Okay. Okay. Did she sign you out at the office? Okay. Video's going to be posted to Teams. Take a look at it. Have a good weekend, man. What is interesting about 2 and 3 and how they relate to 6, and 3 and 5 and how they relate to 15? There is something interesting. Garrett, do you see something? No. Ethan, do you see anything? On page 23. I'm right. All I asked is there something interesting about how 3 and 5 relate to 15 and how 2 and 3 relate to 6? How do they make 15?
If you go up by 3, eventually get 15. If you go by 5 times 5. 5 times 3.
That is true, but what Sahil said is also true. 3 times 5 is also going to equal 15. 2 times 3 is also equal to 6. A quick way to find a common multiple is to just take your two numbers and multiply them together. It might not give you the least multiple, but it will give you a multiple that you can then work with. So it gets more interesting if we have multiples, like 2, 3, and 4. It's not as easy as saying, I'm just going to multiply these 3 together. You could, but the numbers will get big quickly. We can say, well, 2 times 3 is 6, and 6 times 4 is 2 times 3 is 6. 6 times 4 is 24. So 2 times 3 times 6 is 24. So 24 is a common multiple, but is it the least common multiple? Let's use Ethan's method to check. We got 2, 4, 6, 8, 10, 12, 14, 16. My 3's are going to go 3, 6, 9, 12, 15, 18, 21, 24. Actually, let's keep going with the 2. 16, 18, 20, 22, 24. Look, we hit 24. We knew that one was going to work because we just multiplied them together. And then 4. 4 is going to go 4, 8, 12, 16, 20, 24. See, 24 does work. But is it the smallest number that shows up in all three lists? Dakota's shaking her head vigorously, says no. Garrett, that number is?
12.
It is 12. So if you can't find the least, that's fine. Multiply all 3 together and you will get a multiple, but it will mean more work for you at the end. If you can find the lowest one, your life will always be easier. So let's put it to work, shall we? When you're ready, flip the page. So, steps to adding fractions with denominators. Here's the instructions. Here's what we're going to do. What we want to do is we want to find the least common multiple of the denominators, or any common multiple. Any will work. The lowest will always be the easiest, but any will work. Find the number you need to multiply to get to the lowest common multiple, or the common multiple you've chosen. Multiply this number to the numerator and the denominator. You have to do it to both. Just like simplifying, you had to be able to divide both, top and bottom. You have to multiply both top and bottom. And when you have the same denominators, you can add or subtract the numerators. Simplify if you can. That's important. So one of my other grade 9s was like, so now I have to simplify every time? Yes. Now that we've done simplifying once, you now must do for all time simplifying your fractions. So, if I have a half and a third, we already said before, and I'll write it out on my chart again, the chart goes 2, 4, 6, 8, and 3 goes 3, 6, 9, 12. The 6's will work. So I want 2 fractions. When I'm adding a half and a third, I want 2 fractions that each have 6 in the denominator. Now we have to figure out how to multiply to get there. 2 times what is 6? 2 times what gets us 6? 3. So I multiply top and bottom on the first fraction by 3. 2 times 3 is 6. 1 times 3 is 1 times 2 times 3 is 6. 1 times 3 is 3. It doesn't matter. That person probably doesn't want to admit it, and that's fine. We don't need to out them. To go from 3 to 6, 3 times 2 is 6. You can also look at your chart. It's the second number in the chart, so 3 times 2 gets you there. And whatever we do to the bottom, we have to do to the top. What's 1 times 2? Anything times 1 is itself. And now we add. 3 plus 2 is? And what kind of object? Well, we have sixths. So this thing's going to become 5 over 6. Subtraction is the same. If I've got, except I'm going to model it slightly differently, just to show you another way to do it. If I have 2/3 and I have 1/4 and I want to subtract these things, to find a multiple, I'm just going to multiply this one by this one and this one by this one. So I'm just going to go times 4 times 3. I'm not going to bother with the chart. I'm going to see what happens. Because doing this will always give us a common multiple. 3 times 4 is? So then 4 times 3 must also be? And whatever we do to the bottom, we have to go back and do to the top. So then 2 times 4 is? And 1 times 3 is 3, because anything times 1 is itself. Again, you've got the periodic table, I keep calling it that, the multiplication table. And pretty soon I am going to give you back your calculators, but not yet. So, now we're just going to subtract the numerators. 8 minus 3 is? 5. All over 12. Thank you, Hassan. Or Harsh. No, this one's subtraction because of that big sign right there. I want you guys to try these 3 real quick. I will walk around and assist. Using the same methods, I want you to try those. And if you have answers, let me know. Call me over. Yes, yes, yes. Jordan. I love the tools. I really do. They're the best tools. I'm just going to put it over here. Alright. What do you got? Okay. So you need common multiple for 3 and 5. Yes. So what do you have to multiply 3 by? So the way I would write it is like model it the way I modeled it. So once you decide what that number is, write out your 2 fractions. Put 15 minus 15 on the bottom and the 15 on the bottom. 15 on the bottom, 15 on the bottom, and whatever you have to multiply each by, go back and do that. Yeah, I'm going to show you step by step. Go ahead, try to do it. So we had this. So what we're going to do is we're going to say, well, this is equal to something over 15 plus something over 15. Because I just have 15. So then I have to tell what I multiply 3 by 15. So then I have to multiply by 3. But whatever I do to the bottom, I have to do the top. Now with 1 times 3. So then 1 times 5 is? We're just taking the 3 and putting it up there. No, we're taking whatever we have to multiply this by to get 15 and do it to the top. Because it won't always be 3 and 5. This bottom one will be different. It's not going to be 4, 6, and 3. So that number will come out. It's not. You can do it. So you multiply 3 by 5 to get 15. You multiply the 1 by 5 and get 5. So 5 times 3 is 15. What's 4 times 3? That's fine. And now we've got these two at the same denominator, you just add it on. Finish that one. Well, same thing. The subtraction is exactly the same set of steps.
Wait, so do I just add that together and put 15 on the bottom?
Yes.
Or do I just add
Yep.
15 on top and then
Yep.
15 on
And then the 15 on, yep. Yes, first one is good. Harsh? Yes, first one is good. Love it. Danny, love it.
Okay.
Try this one. Let's try this one. How you feel about this stuff, dude? Okay. What are you doing, son?
Got calculator.
Do it. No, well, you don't need, you'll get a calculator.
He wants it.
No calculators.
Oh, no calculator?
Not for this. You now we're going back to the multiplication tables. Harsh, do you need a multiplication table? You don't? Well, you're not getting calculators. Jordan, try it. Get your pencil, I want you to try. Do this question the same way I did this. Exactly the same way. Get it? One. That is correct. You can leave it improper. You can leave the 17. No, I'm saying you can if you like. You can leave it improper, or you can, unless I specify, you can leave it as whatever's easiest. Danny, did you finish all three? Ethan, sit down. Danny, not again. Do not be a source of distraction to your peers. Ethan, turn your whole body face front. Same way you do the other two. Try it. It's just 2 steps. Number 2 is exactly the same as number 1, except you're subtracting instead. Nothing else changes. What was your last one? No, you need to show it. You need to prove that the quota is correct. Nope, because it's exactly the same as the one we just did. I want you to try and figure it out by looking
So
at it.
adding the plus right there, I'll just add another negative.
Put the minus sign there. Right?
How do you do
Well, if you look at 3, the first half is the same as question number 1. And then the second half is the same as question number 2. You're just doing it. If you find a common multiple, what was common multiple for 4, 6, and 3? For all 3 numbers.
Oh. Oh, I got it.
Otherwise, the steps are the same. So when you're more than one fraction, you just find a common multiple for all 3. Also what I said.
Let's see. So our goal is to make
Oh,
our
come on.
denominator
Yes.
the same,
Good. Try the last one.
right? So our goal is to make the denominator the same. Our goal is to make the denominator the same.
Oh, no, that's
In order to do that, we have to
Yes.
find our lowest common
Well,
multiple.
it's the same steps. You can find a common
So
multiple
take
of
your
3
prime
numbers.
numbers. Let's make a little chart. 3 and 5. And you just go up by 3s and you go up by 5. So if we start at 3, what's next? So you do 3.
After you're on the first page, we're going to flip it over and we're going to do
What's the next step?
one more little example. And then I will free you to practice this stuff. I'm just waiting for a few more people to finish last one. We're gonna do that one together, yeah.
3, 6, 9, 12, right?
You gotta finish. Wait, oh, yes, yes.
Do one more.
That will work. Hirsch is modeling
Now do
exactly
something
the
for 5 and
perfect
stop,
scenario.
you get the same number. Do you have the same number? Yeah. So yeah, that's what you have to do from the lowest one to the both are
So are we just adding? Is that what we're doing?
You're not adding. See, you would know this if you listen to the notes.
Stop, or you Somebody said, told me to listen. Forgot about it.
Add here.
Now, what do you multiply 3 by to get it to 15?
Whoa, what is it? Five.
5. So if you're multiplying the third,
Yeah, if there's a ratio.
I believe you.
if you're multiplying the 3 by 5, you also have to multiply the top number. So what's 1 times 5? 5. So put 5 here. What's 3 times 5? 15. Now you're going to put the addition sign. You put the addition sign over here.
Sweet, go ahead.
Put the addition sign over here.
Yes.
Yeah, it's fine. And now, how did
No.
you get this 5?
It was incorrect, sir.
You multiply it.
What'd you do? 3 times 6 is
And
not
if you do that
13.
to the bottom, you also have to do that to the bottom.
You did 3 times 6, right?
Yeah, now you just add that.
18, right?
Now you just add the top numbers, and
So-
your denominator stays the same. Bottom number
The
stays
other
the
ones are
same.
good, right? Yeah, that's
So
just
it's
the
still
adding subtraction.
15, but the top number you add.
This is good, the one you
No,
did here by
just saying
introducing,
the
that's what
bottom
you're gonna
number
have to do.
stays 15,
Okay, remember,
denominator stays the
this
same,
no.
you only add the top.
Why'd you turn into addition?
Same thing for this one, you're only gonna
Change the
subtract the
question.
top, and your bottom will stay the same.
No, you didn't. You
So
said
do the
change
same
the
thing, find your lowest
You're on
common
your own desk.
multiple for 6 and 5 to get them to the same number.
Hey, where's yours?
That's my pencil.
Never mind, never mind.
The bottom.
Yes, you are.
15, yes.
Yeah, Garrett, what'd you get? What'd you get? 1 and 1/12. Yeah, 1 and 1/12. Good. Okay, so a whole bunch of you guys are right there. I'm going to write down what the answers are, and if anyone wants me to do them in detail, I can. What you guys are looking for and what the vast majority of you ended up getting to was 17 over 15, 13 over 30, and 13 over 12. Does anyone want me to do any of those 3 questions? Yes, the last one. Okay, so I'm going to do this one 2 different ways because I saw some people do it my way and I saw some people make it slightly harder but still successfully complete it, like you two. So one way you can do this, let's write this out. It's 3 over 4 plus 4 over 6 minus 1 over 3. What I would suggest is finding the lowest common multiple. The lowest one is, and I have a chart now with 3 numbers. I'm going to put 4, 6, and 3 in the chart, and I'm going to go up by each one. So it's going to be 4, 8, 12, 16, 20, 24. And 6 is going to go 6, 12, 18, 24. And 3 is going to go 3, 6, 9, 12, 15, 18, 21, 24. Boom, boom. If you do this, you will see that the lowest common multiple of 4, 6, and 3 is in fact 12. And so to get that, we're going to take my fractions. To get from 4 to 12, we're going to multiply by 3. Whatever I do to the bottom, I do to the top. Okay, gentlemen, shh, whisper. You can talk, but whisper. To get from 6, we're going to multiply by 2. Whatever I do to the bottom, I do to the top. To get 3 up to 12, we're going to multiply by 4. And we're going to do that same thing to the top. And so we're going to get 9 over 12 plus 8 over 12 minus 4 over 12. And the mistake that I saw a whole bunch of you make was not at this stage, was that you didn't read the rest of the question, you just added across the top. I mean, you did the hard part, right? And so that's great. We just need to, read the question. We're going to 9 plus 8 is 17 minus 4 is going to give us that 13 over 12. I want to demonstrate now what Harsh and Hassan did, because they did it slightly differently. They didn't like my chart. They did it this way. They said, you know what, forget this business. 4, 6, and 3 all go into 24. So let's do 24, because that's the first thing that pops into our head. Let's do it. Over 24 plus over 24 minus over 24. The only one of them, I'm not going to say which, just decided to make this addition. Don't arbitrarily change the question, but I digress. To get from 4 to 24, we multiplied by 6, and so we have to do that to the top. To get from 6 to 24, we multiplied by 4, and we have to do that to the top. To get from 3 to 24, we multiplied by 8, and we have to do that to the top. So they said that 3 times 6 was 18, 4 times 4 is 16, and then 1 times 8 is 8. And now I'm just going to go across the top just like we did over here. Nothing's changed in that regard. The numbers just get bigger and so get a little bit more complicated when I don't let you have a calculator. But 18 plus 16 is going to be 34. 34 minus 8, so this is going to give me 34 over 24 minus 8 over 24. I'm just going left to right. And then 34 minus 8 is going to be 26 over 12. And now we have to reduce. No, it's going to be over 24. Thank you, Garrett. Thank you, Garrett. That's what you were eyeing? Yeah, thank you. And now we reduce. Both of those are even, so I'm going to divide them both by 2. Half of 26 is 13, half of 24 is 12. Oh, look, 2 different ways to attack the same question. We got the same value. If any of you, so like Hassan and Harsh, if you did it this way and you left it right here, you would get 0.75 out of 1 possible mark. You've done almost everything I've asked you to do. The only teeny tiny thing you didn't finish the question. Always, 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 you got to do that last step of reduction. But if you look at this, that's still, technically speaking, this is still proficient. You have shown me that you are proficient in adding fractions together. 75 was my cutoff for that. Rank is the wrong word, but that level of demonstration of your knowledge as being proficient. That's pretty good. You're just not exceeding my expectations because you keep forgetting to simplify the fractions. But you've demonstrated for me the skill set I want you to demonstrate, and so that's what, yeah, you're good. Okay, one more thing to show you, and then we're going to stop stop learning new things and then work on the stuff that we've done. There are 2 ways to deal with mixed numbers, and we're going to look at dealing with mixed numbers now. And I'm going to show you that both ways of dealing with the mixed numbers will both work, but I will tell you this one, method 2, you know what, do I even want to show you method 2? 95% of the time it works. Yeah, notice how 95 isn't 100? Yeah. I'm glad that flagged for you. The reason this one doesn't always work is I'll demonstrate that for you here in a second. Yes, this one. This is the one that doesn't work all of the time. So first I'm going to demonstrate for you method 1. Method 1 is always my preferred method. I prefer to leave things as improper fractions, and method 1, so Garrett, you might not like this one because you always seem to like to go back to mixed. Method 1 has you leave everything improper. So here I'm going to model it for you. To take these things and make them improper, if you recall, we take the denominator, we multiply it by the whole number, and we add it to the numerator. So 2 and 1/2 is going to become 2 times 2 is 4, plus 1 is 5. I multiply this way, and I add this way. Zoom in so we can actually see it right there. And we're going to get 5 over, the denominator stays the same, plus 3 times 1 is 3, plus 1 is 4. I multiply here, I add there, and the denominator stays the same. Now I've got two fractions, 5/2 and 4/3. Now what I can do relatively easily is, as you guys all showed me you could, I can take this and I can put it over a common denominator. The lowest common multiple, or the common denominator with 2 and 3, is going to be 6 is a common denominator. Let's use it. So I'm going to take this, I'm going to put it over 6. It's addition, and I'm going to put it over 6. What did I do to get here? Well, to go from 2 to 6, I have to multiply by, and whatever I do to the denominator, I have to do to the numerator. So 5 times 3 is 15. To get from 3 to 6, I multiplied by 2. Whatever I do to the bottom, I do to the top. 4 times 2 is 8. And now we just go across the top. 15 plus 8 is 23. The denominator stays the same. And if, like Garrett, you would prefer to leave things mixed, we can take this out of improper. We can put it back into mixed if we wanted. How many times does 6 go into 23? It is 3. Thank you, Harsh and Dakota. Because 6 times 4 is 24, 6 times 3 is 18, and then the 23 minus the 18 is 5. We're almost there. So we're going to get 3 and 5/6. That is one way to do this problem. I'm going to show you the method 2 with the same problem, then I'm going to skip the second one down to the third one. So the other way we could do this is we could actually leave these things improper. And when you're adding, it mostly works. Again, 95% of the time. So let's take a look. I'm going to leave the answers on this side. We need to get the same thing. The other method is to say, okay, look, I have a whole number here and I've got a whole number here. I can take out the whole numbers and I can add them together. So 2 plus 1 is, those are going to add and give me 3. And now all I have to do is add my two fractions together. Well, I have to go 1/2 plus 1/3. I'm still having to now deal with this. I still have to go times 3 and times 2 and times 2. That part hasn't changed. But what it's going to give me now is going to be 3 over 6 plus 2 over 6, which is 5 over 6. And then I have to put this piece and this piece back together. Oh, look. I do still get the same value. Does anyone want to take a guess as to where, maybe you can see it here. I know some of you might be able to see this. See where this one becomes a problem? Does anyone want to take a guess? Sorry? You're warm. You're warm. You're not totally there, but you're getting close. This works. I get 3 and 5/6, 3 and 5/6. What happens if these two numbers add to something bigger than the denominator? What kind of fraction am I going to get here? If 3 plus 2 wasn't 5, let's say 3 plus 2 was 7, I get 7/6. So now I've got a whole number and an improper fraction. Sometimes that's what shows up here. And so I would always, always, always advocate for this method. Make everything improper, and then just follow the steps that we've been following. And that will always work flawlessly. Hands up if you're like, I am going to try and use method 2. I would like to use method 2. Like you're like, I want to see more of method 2. I want to see the weirdness of method 2. Some of you? Okay. Everyone who doesn't want to see, who's like, no, I will do method 1, because method 1 will always work, then the rest of you, then I don't need to show you anything else, because then everything else is the same. Subtraction will always work the way you expect subtraction to work too. The only thing you have to do is convert all your mixed fractions to improper, and everything else behaves the same. If you don't want to see method 2, wow, that's loud, then I'm going to give you some stuff to play with, and you can spend the next half hour adding and subtracting some fractions. I want you guys to do ACEs on this page. So ACEs are A, C, E, G, and I. And then I want you to flip the page, and I want you to do ACEs again. And then you're going to flip the page and do ACEs again. But there's more, there's only 3 on each page here. Jovan, give me 1 second, dude, and then you can go. I'm almost done. Okay? So that's what, there's 5 questions here, and then there's 6 questions over there. Over the next half hour, that's what I want you to work on. Anyone who wants to see the weirdness of method 2, I want all of those people to join me at board number 5. Everyone else can just keep plugging away at this. Everyone else can join me at board 5.